week was definitely one in which I think it was very easy to feel the pre-alpha nature of this course. This is a course that's always going to be difficult. It's always going to be time-consuming. It's going to be exhausting because of the nature of what we're trying to accomplish and the difficult nature of this topic. However, I think that this assignment, and to an extent Project 5, were difficult in ways that we don't want the assignment to be difficult. It's not very satisfying when you put a lot of effort in and then you get randomly unlucky and an off by 1 pixel error causes you to mess up the test case, okay? I know that happened to a lot of you, and I want you to know that's not how it's supposed to be. It's a huge problem, and a lot of time is going to come from me over the next year to make sure that doesn't happen again to the next semester's, students. Because I think these kind of assignments, I think a lot of people enjoyed parts of them. It's like a diamond in the rough. I remember when I launched the XR course a couple of years ago. It was very much the same way. We would release an assignment, and while there would be certain parts of that assignment that were really great, there would be other parts that just wrecked students in a way that we didn't anticipate. And I felt really bad about that, and I feel really bad about this too, okay? Know that I really appreciate it. I think I've said this a few times, but I really appreciate it, you hanging in there, and you, kind of getting away from that 100% mentality when we ask you to do so. On this assignment, it was just not realistic to get 100%, okay? And it's absolutely no indication of your abilities or your skill that you didn't, if you didn't, okay? That 20% extra credit was put there because we kind of gauged if you're getting around 80%, that feels like 100% on this project. You've done a lot of work, you made it. But the fact is, maybe you're at 70%, maybe you got 60%, and you were unlucky, right? And you still did a great job, but you just weren't rewarded for that. And I feel pretty bad about that. Right, I really appreciate your patience with this entire assignment. This homework 7, there's a reason I was excited about it before the semester began. There's a reason I'm excited about it now even more. Understand, please understand, your off by 1 pixel errors were caused by the fact that we don't know when you're rounding. We also don't know quite what data types you're using, and we don't know what operations you're doing in your math. There are an endless list of those combinations, of those choices that are valid. The spec did not tie you down into making only certain choices, rounding only in certain times, using only certain data types. As a result, this caused more chaos, especially on the long test cases, than we thought it would. And so a lot of people burned time chasing things and trying to solve problems that don't really increase your knowledge. And that's just bad game design, okay? Just a waste of time. And so the good news is that on homework 7, those pieces of data that you've been computing are no longer something in your hands, okay? Those gameplay logics, those coordinates, those integers, those doubles, those floats are now moved into Lua space. It's the game designer. It's your user who's the one who writes that code. You just have to power it, okay? And so I don't think, Nikhil, did we have like maybe one off by 1 pixel error? And it wasn't off by just 1 pixel. It wasn't a rounding thing. But when Nikhil was going through homework 7, he got all the way through. I don't think we had a single off by 1 pixel error.
We had that? Wait, homework 7?
Yeah.
We had one. I figured it out.
What was it?
It was specifically about which data types were floats and which ones were ints in the image that draws.
Yeah. It's really easy, and it's very clear what you should use now to avoid any of those issues. That is to say, if you haven't had a great time on homework 6 and to an extent homework 5, I think that's going to turn around for you very soon, okay? You now have 3 weeks until homework 7 is due. Now, the assignment was designed to take 2 weeks, okay? Nikhil's telling me it might be easier than we think. Maybe it won't take quite that much time, but we hope you'll take the entire spring break off. You'll relax, you'll rest, refill your heart, your burning desire 4 game engines, and then you'll come back when spring break ends, and you'll be excited to hop back into it. Okay? That's what we hope for you. And just in general, we appreciate your patience. Thank you for hanging in there. And if it didn't go well for you, don't worry too much, okay? Again, we've said it a few times. We're going to make sure this works out for you, okay? You're taking a risk, taking a pre-alpha first semester course, and we're not going to forget that, okay? We're not going to forget that when a final grade time comes at the end, okay? All right, the students coming in the future might not get quite as much leniency as you're going to. But then again, they're going to have an easier time than you will, okay? So anyway, let's go ahead and get to it. We got some stuff to do today, all right? We talked about Lua last time, and gosh, like, it is such a cool experience, in my opinion. In my opinion, it's such a cool, good feeling to be jumping between languages, right, while you're working on the same piece of software. To be thinking in Lua, and then you're thinking in C++, and then you're thinking how to bridge them. And that just really feels good to me. I'm not sure how else to explain it. It feels powerful, and I hope you have that feeling very soon. Very few of you have started Homework 7. I know this. We haven't had a single Homework 7 submission. Wait, hold on a sec. Yeah, we haven't had a single submission. And so I hope you'll get into it before spring break comes, because one way to make this assignment that we think is pretty nice, very not nice, is by cramming that into half the time it was designed for, okay? So please be careful about that. It's best enjoyed over time, okay? Like a fine scotch, I guess. All right, so I've got an engine for you. Why do I need edit access on my own document? What's that about? What's going on here? And not sign in? This is a quick intermission, everyone. Did you notice the Duo UI changed? It's kind of weird now. And now I have to click twice because it always asks me if I want to save my device. But because I'm using Firefox with no cookies, it always forgets. Anyway, you take 388 and you'll be doing the same pretty soon, okay? UbiArt. This is one of the coolest engines that you'll never have access to. This is an engine that was very specifically made for 2D, and it was very specifically made for the artist within. If you are an animator or a 2D artist, then this was literally made for you, okay? Engineers, go away, okay? This is for the artists. It was released, I think, in 2011. It was never really released, but its first showing was for a game called Rayman Origins. They made the entire engine just for this one game. This game, Rayman Origins, Rayman is something of Ubisoft. Anyone know Ubisoft? Ubisoft's mascot is a character named Rayman. You're going to see him in just a second. And the creator of Rayman is also the creator of Beyond Good and Evil and a bunch of Ubisoft's other big franchises. And Michel Ancel. So that's, I guess, how he was able to say, hey, Ubisoft, will you fund an entire new engine for my next game? And if Hideo Kojima asks for that, you just say yes, I guess. So that's sometimes how it goes. Anyway, I want to show you, there are a couple weird trailers out on YouTube for this engine, but I'm just going to show you some of it right now, okay? Take note of how quickly the artist is able to draw and then quickly add bones and geometry, animation geometry, to the designs, the 2D drawings, and then quickly get them animating. So let's take a look.
Un poquito de benzina para tanto coche. Juanito el mecano está para apretar el turno para que quieres el mejor. Para que quieres el mejor. Un poquito de benzina para tanto coche. Juanito el mecano está para apretar el turno para que quieres el mejor. Para que quieres el mejor. Jole, 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 jole. Con tu rueda del sol. Jole, 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 jole. O con tu rueda del sol.
So UbiArt, okay? And if you see here, right, we go from drawing to kind of breaking up the shapes and defining collision shapes on them, right? And it's just very quick and flexible how you can do this. And then also drawing these bone structures, these bone hierarchies onto the object as well, that then allows you to pose them. You can also see that you can quickly kind of combine objects as well. Yeah, you can very quickly make a 2D animation like this. By, quickly if you can draw, I guess. Anyway, there are tools somewhat similar to this around now. One that's familiar is Spine, but that doesn't allow you to draw inside of it, okay? There are other tools that this reminds one of, like Adobe Flash. Anyone remember Adobe Flash? Oh, yeah. I'm going to show that to you in a sec. I want to show you what the game looks like. Video demo there. What does the game look like? Where's the trailer? Here's Rayman Origins. This is the game that they made it for, okay? Let's take a look. This is a really great game.
Peggy 7.
Right? And you can really see the influence of the engine. You've got a lot of 2D images here that squash and stretch. You've got these clear bone structures. Sometimes they literally look like bones. You can produce a lot of art and a lot of animation very quickly if you have an engine suited for it. And so, really wonderful game. I got rave reviews for pretty much everything about it, including its animations and art style. And just the amount of content in this game is pretty impressive for what I believe was actually a relatively small team. However, this engine has been used in other Ubisoft games. If it's 2D, there's a good chance it's using it. This is a game called, let's see here, Child of Light, which has a much kind of different mood to it. Kind of a different art style, too. It feels vaguely 3D, but it's not quite. It's an RPG as well, so not just a pure platformer. Okay. Anyway, let's see here. Gravity Falls. Has anyone seen that TV show? Okay. They started using it for licensed games. This one on the DS, actually.
Peggy 7. Anything you've ever known.
Here, come on.
Mystifying puzzles with awesome gadgets.
Oh, yes, come on. Right. You can see a little bit of that in there on that one. And then Rayman Legends, a follow-up to Rayman Origins. Very beautiful game. It was designed first, second, and third to support those 2D artists, and it was just tailored completely to their workflow, which means it has everything integrated from a drawing tool in there. It has a animation tool, bone tool. It has geometry tools, and it just quickly works. You can compare this to Unity or Unreal. Right, you can't really create your own 2D assets. You can't author those assets inside the engine. You have to grab Photoshop or grab GIMP off the shelf or Illustrator, produce stuff, then bring the assets over, and then add them to the engine. You usually can't animate too much in those engines too either. I think they do have some tools. But anyway, it's just much more integrated and specific and focused for the art genre. It has never been open sourced, and it's not publicly available Ubisoft in general is kind of salty about 2D right now. If it's not a gigantic open world game, it's in trouble at Ubisoft. And it's hard to blame them. As beautiful and as great as these games were, Rayman Origins and Rayman Legends, I'm pretty sure sold about 10 copies. Okay, and we all bought them apparently in this room. And so that's how it goes sometimes. Sometimes even great stuff doesn't sell. That's just how the market is sometimes. That's how it goes. The old Adobe Flash is the closest I can remember to having a widely available version of this. It's not going to look like much because this is pretty old software at this point, but Adobe Flash had the ability. It was basically Adobe Illustrator packaged in with Adobe After Effects, the animation tool, packaged in with a lightweight kind of JavaScript style coding environment. So it had it all. You could make games very quickly. It's why Newgrounds and the Flash ecosystem was so glorious back in the day. Now, the older I get, the fewer of you will be able to relate to that. But I remember playing crappy games like this during my lab hours in middle school and elementary school. Okay? And it was really good stuff. And just making games in this ecosystem was a real joy. That's why so many people, so many young creators on the internet would make stuff and then push it out onto the internet for free. And it was just a wonderful thing. Armor Games, Newgrounds, Albino Black Sheep. It was good stuff, okay? I'm just salty that nothing has come out to replace it. And the one thing that looks like it might is it's like rotting on an Ubisoft server, GitLab server somewhere, okay? So pour one out for Ubi Art. Hopefully it will see the light of day at some point. And if it does, chances are we won't have enough documentation to make much use of it. Anyway, that's how it goes sometimes. If any Ubisoft employees are watching the stream, okay, all right. Anyway, okay. Reminder: don't aim to complete homework 6. You probably will go insane. A few of you maybe already have. Please move on to homework 7 as soon as you got a nice big chunk of points on homework 6. You're going to be okay. Homework 7 doesn't use all that much from homework 6. Homework 6 is mainly about getting a feel for what it's like to manage stuff in that continuous 2D space, deal with collisions, and the performance stuff, okay? If you've gotten some of those points, then you probably got a lot of what we wanted to teach you on homework 6, so just move on. You can come back later if you got some extra time, okay? You can always, that's the thing about version control, right? The whole point is that you can just go back in time and revisit old code. You can even resubmit it to the autograder if you want to scoop up some more points toward the end. Try and get a good push on homework 7 before spring break begins. I'm guessing Nikhil and Ravi will have an idea of how much they might want you to get done before spring break tomorrow or on Friday in the discussion slides. I can't decide how much I want you to get done. But here's the thing. You can look at how many test suites there are. And I'll tell you, we ran out of numbers when we were numbering the test suites. Okay? So suite 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C. The drop deadline is way in the past, everyone. So don't even think about it. Anyway, the good news is that there aren't going to be off by 1 errors, and a lot of these test suites aren't that difficult at all. And so they're going to go by very quickly, but you should get on with it, okay? Try and hit 4 or 5 maybe. That'd be a really good step, and then you can finish the rest later, all right? There aren't really any performance test cases, are there? There are. There's like 1 or 2.
I still can't figure out what optimizations you did. But you did something.
Okay. There aren't that many, okay? If you can't get them, you're missing like 2 test cases out of like 50 or 70. 71. Holy crap. Oh, it's going to take a while for the autograder to get through those. Okay. Good thing we have so many. Anyway. Okay. Crunching hard when you return is not a good idea. Don't do that if you can. But if you have to, you got to do what you got to do. All right. Just try and stay healthy and do what you can. Be smart. Let's talk about homework 7 a little bit more, okay? This is really the homework where I feel like the engine finally feels like a legit engine. By the time you are done with it, no joke, by the time you're done with it, it's going to feel a lot like Love 2D. Has anyone used Love 2D? It's going to feel like Love 2D mixed with Unity, okay? It's going to feel like a 2D Unity where we're missing the nice, beautiful editor. Maybe over the summer you can write an editor, because I kid you not, all you really have to do is write a basic UI tool that can help you edit the JSON files faster, right? And there are lots of great libraries to help you serialize, deserialize, and edit JSON files. And so it might be a really interesting challenge to go do that, okay? Before, we were stuck. We've been stuck forever in this top-down kind of adventure, exploration style game. Yeah, there's some avoidance, but there's no real combat. The mechanics are pretty shallow. However, now we've been freed, okay? We can go over to a shmup or a cute-em-up or whatever, or a racing game if you want, or a platformer, whatever you want to make. A 2D fighting game, Street Fighter style, you can do it as long as it doesn't involve 3D. And by the way, there might be a test case or two toward the end that is 3D, okay? So you should watch out for that. How can we make a 3D game if it's a 2D engine? Well, you might discover how, okay? We're going to see. Anyway, different genres are enabled by allowing different logic, okay? Right here, we've got a bunch of hard-coded rules in our C++, but we're moving those out of your engine now. Now they're going to be in Lua, and Lua is the scripting language that helps us bridge this gap and truly free our users to do whatever they want. This week, it's a new language and a new architecture. It's a very exciting time, okay? And hopefully you'll enjoy it. This is a 2-week assignment. There's going to be a lot to take in, but hopefully none of it will be all that frustrating compared to homeworks 5 and 6, okay? Some architectural changes. Your scene files are going to start to look a bit different. They're going to start to really look like the Unity and Godot scene files that we saw earlier on in the course, okay? Basically what's going to happen, and I think you saw this the other day, but basically you're going to have actors. Actors are going to be literally just a list, in this case a dictionary, of components, okay? Each component is going to map to a type, okay? To a Lua file, and in those Lua files, you're going to have component types. Okay? For instance, this keyboard control, you're going to open up the keyboard control.lua file. You're going to find all the logic that does the thing. You're going to find some nice lifecycle functions, and you're going to be able to override some variables, and it's going to be a good time. Okay? If you've ever wondered about this, this structure, right? Components. Why do you keep saying this word? Right? Components are a very common method of code reuse in creative domains. Okay? I'm going to explain to you why this is very soon. If you've taken 494 or XR course, you probably already have the spiel on components, but a lot of you haven't taken any of those courses. And so why are components a big deal? Why don't we just use inheritance for everything? We're going to explain that pretty soon. Okay? I got some tips for you on this assignment. Try and keep a consistent pace. It's very difficult to kind of pace yourself. I think there are a lot of other things. If there's another thing on your mind, then a homework like this might get delayed when you've got 2 weeks to do it. But be very, very careful, okay? Because this can be very unsatisfying if you cram it, but it could be very satisfying if you take it at a nice, decent clip, okay? I think you're going to find this to be a very satisfying assignment, but you're going to need time to get a feel for how Lua works and how to just read the language. It's not that complicated, but there are some weird things in this language I'm going to show you today that might blow you up, okay? There are a lot of features you're going to have to implement to support your Lua scripts, but they aren't all that difficult, many of them. Some of them are tricky, and you'll need to think about it. Some are basically trivial, just a minute or two, and it's already working. And some are going to actually require you to think about how you're going to manage all these references, how you're going to deliver component references to the right place when a Lua script makes a certain function call, okay? And so you want to be careful, all right? 2 weeks can give you a bit of a false sense of comfort, okay? The best way to get a feel for whether you're on pace is to start just working on it. You'll get a feel for how difficult these things tend to be, and you can start to really gauge whether you need to put in that hour or two this evening or whether you can skip it and rest and deal with something else, okay? I think this is the coolest assignment in the entire course so far. That's partly because I'm not finished with homework 8 or 9. So who knows, maybe those will be really great too. Maybe they'll get canceled if we run out of time. Imagine them getting canceled. If they got canceled, you'd have to just enjoy the rest of your semester.
Oh, no.
We can't be having that. So Nikhil and I and Ravi have been talking about what happens if I mess up and can't finish homework 8 and 9. And our idea is basically we let you start on your custom engine feature 2 extra weeks. Heck yeah, that sounds pretty cool, huh? And if the faculty are annoyed with me at all, I can just say it's the first, it's a pre-alpha version of it. I'm going to fix it, okay? Don't worry, okay? Anyway, that's not the worst ending in the world, I think. And your engines would still be pretty cool. After this assignment, your engines are going to be awesome, okay? No joke. At the completion of this engine, you're going to have a baby Love 2D or mono game or pie game that is mixed with the scene structure and organization of a Unity, okay? So you could go either route if you wanted to add onto the engine. Off by 1 pixel errors are going to be basically history, okay, on this assignment. So it should be a breath of fresh air, should be much more satisfying to you. And that's all I got, okay? Any questions on this assignment? Okay, you'll have more as you start working on it. I hope you'll start working on it soon. You'll have a good time. All right, no question.
Do you need to keep anything like from the homework 5 or 6?
So you might keep, you're going to keep some stuff, okay? Like for instance, homework 5 was all about introducing SDL and introducing good APIs for text rendering and audio rendering, and especially like the caching behavior of some of that stuff. You're going to want to keep that for performance reasons. But basically, you're going to be hooking those technologies you built for homework 5 and 6 up to Lua calls in homework 7, so that your game designer who writes the Lua is going to be able to make those calls and be able to render stuff, okay? So the answer is yes. Yes, homework 5 especially is very important for homework 7. Anyway, I want to show you a little bit of Lua, okay? We wrote, I think, a tiny bit of Lua code in our engine. On Monday, we integrated it, okay? So I don't want to hear that you're having trouble getting Lua to work on Windows, okay? On Mac and Linux, okay, maybe that's a bit tricky. I don't know. I haven't done it in a while. But on Windows, I hope all of you can get going fast so you can start working and get satisfaction out of that. Okay, I really like this online interpreter. This is a Lua interpreter, and here we can see our first Lua program. It's right here for us. I click run, and it immediately runs. Okay, I guess that's part of the magic of an interpreter. It doesn't have to do any kind of compilation, unless maybe it's a just-in-time compiler. And I don't think this is a just-in-time compiler they're running. I think this is just vanilla Lua interpreter, which is what you'll be using. Anyway, what is there to say, okay? If you want to render, if you want to print something, you can concatenate stuff. So for instance, hello, and then ... and then 498, right? The ... is concatenation. If you have a reason to do some counting, do some iteration, okay? A for loop is typically what you'll do for that. The syntax is a little bit weird, though. It feels like it's trying to be Python-ish, but it's not quite. It's not quite as expressive as it can be in Python. I think Python and Lua actually launched around the similar time frame. So I don't think they stole ideas from each other necessarily. Anyway, here's how we're going to do it, okay? Let's go. For I equals, I think this is 100, do, end, okay? All right. Okay, we're going to see if this works. Let's just print the number. Let's just print I, huh? There we go. It worked. Okay, so you don't have any parentheses that you use here. You don't have an iterator like a I++. No, it's just kind of number, comma, 100, and that's how you can kind of iterate through a number range if you want to. But what if you have like a list of values, like an array of strings? What are you going to do? What's the name of the array type in Lua?
Table.
It's a table. Okay, what's the name of the dictionary type in Lua?
Table.
It's a table. Oh no. Everything is a table, okay? Basically, everything is a JSON blob. Okay? You got a bunch of JSON for your data structures, okay? Here is how we're going to create a table. Okay, we're going to create an array. Let's call this favorite foods, and I'm going to create it, and you always create your data structures with these curly braces, okay? And let's go ahead and start adding some foods. I got Notai in here. I got Totoro. What do we got? What else we got? Joe's Pizza. And one final. Overrated.
No, I agree. That's the only thing.
The two ends, I think. Ginger Deli. We got last one. Let's go. Yep, that's the best one in town right here, actually. You know why? Because my friend runs it, and I get to sit in the back. We used to have our office hours at the Ginger Deli, and sometimes when I'm back there, they bring me free pho. It's great, and free sandwiches. Anyway, they hired a bunch of my students to make their app, which is really cool. Anyway, favorite foods. So let's say we have this table. It's kind of an array, and we want to iterate through it. What do we do? What do we do? Well, I think what we could do, actually, is we could do the same thing that we did up here. I'm going to get rid of this, actually. And we could probably, I think we can index in by doing something like this, I. Now, I almost never do this in Lua. I'll show you why in a second. So I'm not sure if this is going to work. Maybe it will. This is totally going to blow up because it's going to go over 100. But let's see what happens. Yeah, okay, here's what happens. So it prints Notai, Totoro, Joe's Pizza, Zingerman's, Ginger Deli. So it prints everything, and then it starts printing nil. Okay, nil is the value for null. They just named it differently, kind of. And that's just how it's going to be. Another thing that's interesting is you might want to iterate from 0 to 99, because that feels pretty natural as a programmer of any other language. But guess what's going to happen? Oh my gosh, look at that. They, as the video from Monday told us, arrays in Lua are 1 indexed instead of 0. Okay, and this will mess lots of things up if you try and program in Lua like you do in C, okay, or C++. All right, but this is still fine. We would like another way to iterate through this table, however, right? One of the kind of cool new trends that's popped up is like the for each iteration loop, okay? I think this is called like range-based. Anyway, basically you just say, give me all the items in this container, iterate through them one by one, and then we're done, okay? No worrying about indices or anything like that. Well, what we can do here to iterate through this favorite foods table is we can go, for instance, we can go for I val in, or I can even call this I food, in I pairs, okay, favorite foods do end, okay? Now, this is going to look strange for a second, but here's all you need to know for now. We can print the index. We can also print the food. I'm going to actually do both. I'm going to do print I ... and then food, okay? Food should be a string. I should be an integer. Interestingly, Lua can automatically toString an integer, but it won't do this for a Boolean. So if you've got a Boolean in here, what you have to do is type toString I, okay, or bool, whatever. It's very weird. This language is kind of weird. I got some questions for this language. And there you go. Okay, we're iterating through the indices and the food at the same time. Okay, here's the thing. Every value that you put into a table is kind of best thought of as a dictionary that is sorted sometimes. Okay, and so you're really iterating through key value pairs. And if you use I pairs in particular, it's going to guarantee an ordering for you. Okay, so it's not going to mess up or mix up the order. If you use normal pairs, it might not guarantee that order. So we might end up at like 2 and then 1, and then 3, 4, and like that. So it's a bit spooky. Pairs, I pairs is what you should use to iterate through an array, through a table, when you just have a normal kind of array-style table. But if you have something that looks a bit more like a dictionary, let's say that we have not favorite foods, but we have like Mario properties, okay? And we've got like HP is equal to, 100. Wait, can I do this actually? Can I do that? Nikhil, do you know if I can do that without the quotation marks?
I don't think so.
You don't think so? Okay. I'll leave it safe. We'll make it a string. HP equals 100. Attack equals 2. Defense equals 1. Okay. Let's see. Backup equals Luigi. Okay. We have this dictionary that's very flexible. It has string keys pointing to integers, but also to other strings. And I think you can make it even crazier than that. But when you have that kind of diverse dictionary kind of style table, you want to probably use pairs instead of I pairs. Instead of I, you'll basically use key and then val, you might call it, okay? Then what we can do is we can say key equals val, and let's just kind of see what we get here. Oh, we got an error, okay? 2, so it doesn't like this actually. Do you know why? Equals, it doesn't like this. Let's see. Is this going to work? No, it doesn't like this at all. I don't think we can have strings, actually, as our keys. Can we do that? Bad argument 1 to pairs table. Oh, yeah. Oh, yeah. We can't use strings. Yeah, so it's totally wrong. Anyway, so here you go, right? This is how it be. And let's go, what was that one? Backup equals Luigi. Okay? Right? And so here you go. That's how it looks. So that's the takeaway. Tables are just pretty much dictionaries. Okay? They're basically JSON blobs, and you can have diverse data types in there. You can iterate through them in a guaranteed order way if they're like numeric keys. If you don't provide keys at all, then they will automatically receive integer keys. And that's how it be, okay? Anyway, what else could we care about here? Well, there's this topic of classes and inheritance. Now, Lua, it doesn't matter if you're programming in C++ or Lua or whatever, okay? You're eventually going to want some concept that at least resembles classes. You want to be able to make instances of that class. For instance, instead of having Mario properties, I might want to have a hero class. And then I want to create multiple heroes, okay, and spawn them in and have them work and all have the right properties. And I will tell you, I might not remember how to do this properly, and I might mess this up because I already messed something up. It's a bit funky because tables in Lua are basically what you use to fake classes. Lua doesn't really have a class concept so much, but they do give you just enough minimal features to kind of fake having a class system, okay? And so that's what we're going to do, okay? That's what we're going to do. Here's what we're going to do. Let's create a table, okay? This table is called Mario properties, but I'm going to create a table called, let's call this character, okay? This is a table, so I'm going to create the table like this. Now, this is basically JSON, except unlike JSON, we can do really cool things. Like we can say that there's a function, okay? Let's call this like update, or like let's call this the take damage, okay? Take damage is a function, okay? It's a function that takes a reference to self because this is an instance function. It's not a static function, it's an instance function. So you want to give it a reference to the object that it's using. This is basically like Python. You know, in Python class functions, it also has that self parameter. Let's put a do in here. I think is that a do? Do I put a do in here? No, I don't. I put an end, okay? So let's say that we got a function here, but we also have a piece of health. So HP is a value. It starts at 100 by default. Let's say that speed is a value that starts at 5 by default. We've got a take damage function, and what's going to happen is you send in a value. So let's call this delta, and basically we're going to say self.hp equals self.hp plus delta. Do you wonder why I didn't do self.hp plus equals delta? Do you wonder? Is it just gnawing at you? It's because Lua is so minimal, they couldn't be bothered to give us a plus equal operator, okay? And so you're going to be writing a lot of this, okay? It does sometimes feel like your Lua code is just a little bit ugly, and that's the price of ultra minimalism, I guess. Anyway, but I think one could argue that minimalism would be allowing you to add that one character to get rid of this. You know, make your line shorter. Is that more minimal? Yeah. All right, whatever. Anyway, so this is how it's going to be. We need a constructor here. Okay, we need a constructor if we want to create instances of this table. Here's what we really want to do. We want to be able to basically say Mario equals character dot new. Okay, this is kind of the standard for how you call a constructor and create a new instance in Lua. Now, there's nothing special about this new function. We have to create it ourselves. You know, we might do this for other characters. Peach equals character dot new. Luigi equals character dot new. And we want to make this happen. So guess what? We're going to create that new function. So new equals function. What we're going to do here is we are going to create this function. And basically, it's going to create an instance of the table. So let's do that. Local, let's call that new character equals character. I think this is what we do. Is that what we do? I think that's fine. Is that fine? Okay. We're probably going to get some explosions here. Anyway, new character equals character. What we then need to do is we need to return that new character, but we need to tell this table. Actually, no, we don't do this. We do this right here. We create a vanilla empty table, okay? We're going to return that table, but not before we tell this table that it should refer to that character table, okay? Now, that probably made no sense at all. I have to explain the concept of meta tables to you now, okay? This is going to get meta. Here's what we're going to do. Set meta table, okay? Let's go new character. That's the table we're setting a meta table for. I'm going to create a new table. This meta table we just created is going to have the index property set, and it's going to set to character, okay? All right. Pain, okay? You have to kind of remember this, and it does eventually make sense, but it's kind of weird. You really wish you could just, like, do colon somewhere and then, like, inherit from this table, right? A shorthand. But no, Lua is not going to let you do that. They deprive you of features, and the result is that you have to write more code to set everything up. Okay, so here is what is happening. I wish I had a whiteboard to draw on. I kind of do. Maybe there's some markers. So basically, actually, I'm going to see if I can do this, okay? Let's see here. Oh, no. Oh, no. This is not good. Okay. Oh, it's been on here too long. Do we have any, like, water or something? Raul, we got a malfunction on the... Can we, like, get this... Do we have any stuff? Okay, the gist of what we're going to do here is if you have a table, let's say you've created an empty table, okay? See this empty table right here? There's nothing in it. It's just a JSON blob. Well, you can associate another table with this new table. It's called a meta table. And a meta table is simply a table that can hold some special values, okay? Those special values change how the first original table works. Now, one of those values, the index value, basically says, hey, if you look for something, if you look for a function or a value on this table, but you don't see it, go to this other table and grab it there instead. And that's kind of what inheritance is. I've got this object. I want to call a function. Oh, it doesn't have it, but it does have a parent. So look at the parent. Oh, the parent has the function. Use that one instead. Okay? And that's how it be. Okay? Yeah. And I'm going to draw that out for you again. I wish I had a little bit more, like some slides to tell you exactly how this works. I might have messed up the syntax here as well. But anyway, where'd my markers go? Here we go. Okay, so on this line, the curly bracket right here, it creates a new table. Let's say we've got the character table. By the time we get in here, the character table has been established. Okay, we got HP equals 100. We got speed equals 5. We got the new function. We've got the take damage function, okay? And this is the character table, okay? We're just going to call it that. All right? Now, this table is just sitting there in memory, not doing much. When we get to inside this new function, what's going to happen is we create a new empty table, okay? New empty table, and this one's called new character, okay? All right. Now, this new character has nothing inside of it. It has nothing inside of it at all. But what we do is we set a metatable. We create a metatable right here, okay? So we're creating this kind of new anonymous table, and the only value that it has in it is index, okay? That index value is being set to point at the character, okay? Now we got a metatable right here, but this function call is what associates this table with this one, okay? It's gonna, after we call that, it's gonna have metatable equals, and it's pointing to that, okay? As a result, from now on, when we return and mess with this table, if we ask for the speed or the HP of this table, it's going to say, well, it's blank, it's not there. You see, it's not there. But what it will do is it will say, wait a second, this table has a metatable. Let's check the metatable. The metatable says that the parent, the index for that new char table that we're returning, is the base character parent table, okay? So this has created an inheritance kind of chain, and what's going to happen is we're going to end up grabbing, if we ask for speed down here on the new char table, we're going to grab this one up here, okay? It's actually kind of making a copy of it, sort of. But anyway, I'm not sure if this is going to work or not. It's going to get angry at us. 14. What's wrong with 14, huh? Oh, you forgot a comma. That's another Bigfoot gun right here. Remember, this is pretty much JSON we're dealing with. You know how JSON's really touchy if you got a missing comma or if you got too many commas? Same thing, okay? So don't forget your commas. Every one of these, even if their functions are just a key and a value in a dictionary, a JSON object, basically, okay? Hey, there we go. It did break. That's cool, okay? We've got these characters here, and I'm going to say, hey, Mario, you need to take damage, okay? Here's another foot gun, okay? I'm going to call take damage, and I'm going to give it -5. So Mario should have negative 95 health now, right? And I'm going to print it like this, okay? Mario.hp. Okay, this is not going to work. What's the problem? Wait, what's going to happen? I don't know. 15, attempt to index a null value. Okay, right here, something has gone horribly wrong. Well, here's the deal, okay? I want you to look really closely, okay? Look really closely, okay? There's a huge difference between these two right here. Which one should we use? All right, one of these, okay, one of these will pass in a reference to the object itself automatically. Okay? If you call Mario, if you call a function with the double dot, the colon syntax, it will feed in a reference to that table into the function, aka Mario gets put into self, and then -5 gets put into the next parameter. Okay? This is really important. If we call Mario dot, then that reference to Mario is not getting put into self. Instead, I think -5 is going to self, and that makes no sense at all. Okay? And so, this seems very arbitrary, doesn't it? The reason we call a character dot new is because we don't have to pass anything like self into that function. Okay? It wouldn't make sense to. I mean, its whole point of dot new is to create a new instance, not alter one that already exists. Okay, so I came up with an ingenious way to know the syntax difference. Okay? Does anyone want to... Okay, how should we remember? How should we remember that colon means that the self parameter gets filled automatically? Gets sent in automatically. Yes?
Maybe the top dot is the self.
Bingo. The extra dot is the self reference that you're sending in. Okay? That's the easy way to remember this. Okay? You got one dot, you're not sending in the instance reference into self. If you got two dots, that extra dot is the instance reference that you're sending in. Okay? So that's how you remember it. By the way, I think that you can get away with, by the way, that's how you do a comment, dash, dash. You can get away with doing the single dot, but you have to send in like this, okay? And that's going to work because now we're sending in Mario, I think. I think this will work. I don't know. I haven't tested it. 95. It worked. Okay? Sound like 90 minutes of sleep. My shining moment as a lecturer. Improv to victory. What's up?
I'm just curious, if you did Peach not take damage but left the Mario there, would it have the same effect?
Which one? Right here, you mean?
If you did Peach not take damage, you pass in Mario.
And I pass in Mario?
Yeah, but without doing the semicolon. Or
Yeah.
With the dot?
Yeah.
I'm pretty sure Mario's going to take damage on Peach's behalf. Okay? Which seems appropriate. Let's try it, though.
Peach is kind of there.
Okay. Let's get rid of this. Yeah, that's exactly what happened. Yeah, that's kind of strange. Anyway, you know you're starting to understand a language when you can like make those kind of weird predictions. It's like, wait, what if we mess this up? And you can follow it through and correctly estimate. Your mental model, that means your mental model starting to get filled out to the extent that it can actually predict the future, which is the whole point of building up a mental model in your brain in the first place. Yes?
I'm just confused by how, when you're doing character.new,
Yes.
you're setting the meta table to reference character.
Yep.
And you're sending an empty table. You had an empty table that you're setting that index to.
Yes.
My question is, how are they not all like pointing to the same character table? Like, how is it separating into new character tables?
Okay, so set meta table, I'm pretty sure, basically establishes a pointer, and this is the pointer. It basically says, when you're dealing with this new table, aka Mario, when you ask Mario to go and take damage, when Lua basically sees that you're about to edit a property that isn't on Mario but should be, it basically creates a copy for you. So that means we don't end up messing with or altering the original base table's data, but it creates basically a copy of that data, puts it on the changed instance, so that kind of prevents Mario's taking damage from messing with Peach or Luigi's damage as well, health. I think that's what happens. Because I was confused about that too, and then it just worked the way I hoped it would. Okay? It's kind of rare in Lua. Yes?
I think it might be the case that when it reads self.hp, it gets it from the character table, and when it sets it on the instance.
Yeah, that's what I would expect. But I don't know. I'm not entirely sure. I'm pretty new to this language as well. Anyway, I think most people learn Lua and start doing stuff with it without looking too far under the hood. But you're engineers. You're good engineers. And so your curiosity, I think, will be a very satisfying thing in the next couple of weeks. Learning this language, getting a feel for why it works the way it does. A couple of things to point out. There are some discussions about topics like why did you one index the language? Let me see here. Which one was it? Lecture 11. It's in here somewhere. Where is it? Okay. One of my favorite ones. You notice how I used local? You notice how I used local right here, right? Okay, if you forget to put local here, you're creating a global variable called new character. And that's going to mess things up potentially for you, okay? And definitely, at the very least, it's going to start to pollute the global namespace until eventually you try and reuse something and it's all weird and you're messing with data you shouldn't be messing with. And there's this question like, why did you make your variables like global by default? This was asked to the creator of the language. Let's see here. Okay, so in your experience, what are the most common mistakes developers make in Lua? Mostly for people that came from Python, but also other languages, aka anyone who's programmed before, is that they forget to use local for local variables, and because of that, they're polluting the global space too much. And so, okay, why did you do this? Why did you make this choice? And I think the best answer could be like, yeah, we just messed up, and now we can't change it without breaking backward compatibility. This is a very funny question because if you think about any programming language but Python, they're all kind of non-local by default. And that was my response too. Like, wait, what are you talking about? Read the next paragraph on your own time. It makes no sense to me at all. And I would have accepted we didn't think about it that hard. Can anyone make anything of this? We do have other stuff to talk about today, so we got to get moving. I think they're saying like Lua is non-local, but actually every language is non-local when you think about it. What?
Are they saying like if you just declare something not in a class or a function, anything that like includes that file can access it?
Yeah, but that's not what anyone's talking about when they ask this question.
Yeah, I mean that's not global, but I guess any file that sees it. Yeah, that's weird.
I haven't had enough sleep to digest this. Ravi, take it.
JavaScript is the same way.
Is it?
You do nothing, like just variable equals something that makes it global.
They introduced let, I think.
Yeah,
to fix
var,
this.
Which is function scope, and I don't know why you would ever want that. It's like a global for the function you're in. So if you use var or something, it doesn't matter how many nested deep it is. As long as you're in that function, it behaves like a global function.
Huh. Okay.
Yeah, I don't know why you'd ever want that.
Huh. Okay. They just keep adding features to that language. So there's this idea in game design that like very rarely do you improve a game's design by just adding to it. Or if you add peripheral things like power-ups, it indicates that the core of your game is flawed. The central idea is flawed. And this feels a little bit like that. But anyway, one approach to deprecation that you can do if you really care about not breaking compatibility is you could introduce a new feature and then with documentation and social pushes, you can make that the default. And then one day long in the future when no one's using the old keywords, you can get rid of them maybe. That's one way to fix things with a language without blowing everyone up. Okay? Anyway, yeah. There you go. Okay, other foot guns. Yep, we got that one. We got, default, local, non-local, global scoping. It's crazy. It's crazy out there. Be careful, okay? I don't think there's anything else I want to tell you about. This is pretty much all you need. And the assignment spec for homework 7 will give you actually some code to help you do certain things like establish inheritance between two table references, okay? Just because that stuff's kind of messy. And the syntax is a bit ugly with how Lua Bridge wants you to do it. You have to use the raw like Lua stack to do some of those things. And I don't want to, you've got enough on your plate. Okay, we'll just give that to you. Anyway, Lua is still a pretty cool language, and if you overcome the foot guns, I do think you'll appreciate how easy it is to just get it building, which is really great. Okay. That's like the killer feature if you think about it. You wanted Python, but you spent 2 days trying to get it working, and then you spent 5 minutes getting Lua working, and it just works. So you're just going to roll with Lua and do whatever it takes. So, right? Halo Infinite used Lua for a lot of their scripting. I know this because I got so many students on that game. The game was a mess. Yeah, or so they say. Not sure how much I'm supposed to say. Anyway, they used Lua on it, and the thing is, Lua is a very simple language, but it makes it very easy to build stuff up on top of it. And so you'll have a lot of engines, and you'll get into a lot of Lua code bases. I was just looking at Gary's mod. Anyone play that? That's a Lua-powered system. So basically, you step into a Lua code base for an engine, and you quickly find just massive amount of bespoke custom features that were added to the language, not really added to the language, but features given to you by the engine, integrated with Lua, to basically make it as featureful as many other languages are, okay? You just have to deal with some of the weird syntax. Okay, anyway, what do we want to do here? What else do we have to talk about? One big question is about components, okay? And I'm not going to give you the Scribblenauts talk, okay? But I'll explain what I'm talking about when I say Scribblenauts. Scribblenauts is a game that sounds like it shouldn't be possible. It's a game that you can type any word and it just pops up into existence. And you can use those objects to solve puzzles, okay? So if you want if you want a professor to spawn in to help you, okay, you just type professor and you got a professor, okay, with this kind of simple art style. And this refers to any object. So you say, well, Austin, surely they can't have a jackalope because that's like, that's a pretty rare animal. It's like a mythical creature. But they do, okay? They've got a jackalope, which if you don't know is a bunny rabbit with antler horns, which is really funny. On the rare occasion, you'll find like a game set in the woods, and you'll go into a cabin, and you'll see mounts, like you sometimes do in cabins, and it'll be a jackalope, like they found one. And they found the one jackalope, and they took it out. It's so sad. Okay, how does a smallish team build a game with seemingly infinite content? One really cool thing about this game is you can actually not just spawn in a jackalope or a professor, but you can add adjectives to it as well. Okay? For instance, you want a big jackalope, a big professor, and it will just work. You want a ice cold, right? An icy jackalope, an icy professor. They'll spawn in with a blue tint, and they'll be very cold. Okay? And that's just how it works. When it comes to building out a lot of good features like this and tons of content, a small team, this was made by a team of only about 50 people, has to reuse as much stuff as possible, okay? They have to use a lot of inheritance, but they also use a lot of composition. In particular with the adjectives. In the game, basically every adjective was a component. In Unity, this is what components look like, okay? You click on a game object, it's called, basically the actor of Unity, and you'll see a list of all the components that that actor uses, okay? Each one of them is a script, a C# script. That's Unity's scripting language, as opposed to our Lua, okay? You can see each component has these properties that can be edited and adjusted without changing the source code of the component. And you can even turn off and turn on, enable, disable components as well. Components can grab references to other components sitting right next to them, and can mess with them, can turn them off, turn them on, can change the variables, right? That's a big part of programming in Unity. It's also a relatively big part of programming in Unreal, okay? Unreal doesn't tend to have as many components. Unreal tends to have really big, chunky components that do a lot of things, but they still have a component-based system, okay? You can see 2 components on our actor there in Unreal, okay? In our course, It's the same way. We're going to build our actors to basically be big container components, okay? And the components you have define what you do. In the past, we would actually say like, oh, your view image for this actor is X. But that's not going to happen ever again, okay? What you're going to do instead is you're going to say, hey, Donna is an actor, right? The flying donut pilot is an actor who has a sprite renderer component. This is a component type written in Lua where you can hand it a sprite and it will draw that at a certain location. What location will it draw at? Do you know? The sprite renderer doesn't have any position properties in it, so how does it know where to draw? What's the situation? How does it know? Yes?
Grabs the position data from the other transform component on it.
Bingo. When we look inside the sprite renderer code, you're going to see that it grabs a reference to this component, the transform, which does have an X and a Y position. And that's where the sprite renderer will draw. If you don't have a transform, it ain't going to draw for you. Okay? And so that's how it goes. And each one of these component types is a Lua file, and you can read it and you can see what it does. And it allows you to customize really easily. It allows you to reuse a lot of code as well. Okay? This is how you reuse code. Now, typically in like EECS 280 and 281, we're taught to use inheritance, which is a fantastic method of code reuse. It's obvious why it's one of the first things that you learn to reuse code, after functions and perhaps classes. All right? It's a very popular method of code reuse. It has wide support in all these popular languages. The usage is basically like this. You establish an ISA hierarchy. Okay? Professor is a human. A student is also a human. Okay? A jackalope is a rabbit. Humans and rabbits are both objects. And at each level of this hierarchy, we put common data and we put common functionality. But as we go down the hierarchy, we also kind of customize how certain functions work and stuff like that. In C++, how many of you have used inheritance so far in your engine? I've used no inheritance at all. And I've never felt the need to, for the most part. Anyway, so you can set this all up. Inheritance is pretty good stuff. Here's how it looks like to establish the teacher and the student being child classes of the human, okay? And it's not bad, okay? Even in Unity, you often use inheritance. In fact, you'll have components that derive from other components to kind of share logic across components if you want to. In Unity, mono behavior is just a synonym for component, as far as you know, okay? And in Unreal, the same thing is the case, okay? You've got components that are inheriting from components, all right? I have a scenario for you, because we're going to discover that inheritance is not perfect, all right? And by the way, how many of you have seen this talk before? How many of you haven't seen this talk before?
I've seen this one this semester.
Yeah, you have. Okay, a few of you, all right? Well, it's a good refresher, all right? So let's say that you've got a panda. You work at a game studio, all right? Congratulations, good job, all right? You work at Stardock, and they're making a new panda game, okay? They walk in, right? They walk in, and they say, hey, your boss says, hey, we need a new panda for our game. What are you going to do? Well, you have a feeling that this panda is not the last thing, entity, actor, that your boss is going to ask you for. So you set up an inheritance chain. You set up an ISA inheritance chain. You got panda down here. A panda is a bear. A bear is a mammal. A mammal is a living entity, and a living entity is an object, okay? And you've got all the different functionality and data spread throughout here, okay? For instance, in living entity, you might put like HP, health. You might put like energy, sleep level, hygiene level, okay? Basically all the Sims stats. In mammal, you might have some custom stuff. In bear, you've got like a fur function or something that gives your object, your character fuzziness. And then you got panda, okay? Right? The next day, your boss comes in and demands you create an icy panda, a frozen panda. Where do you put this on the inheritance chain? Yeah, Robbie?
If you've done this, then just stick it on Panda.
Yeah, you stick it under panda. It's not that hard, okay? Right, this is basically a panda, pretty much, except with some additional ice logic that we put into ice panda, okay? All right. Now, Lovecraftian panda is the next request the next day, okay? And you do the same thing, okay? It's basically a panda but has some unique Lovecraftian stuff. The weird situation kicks in when you are asked to create the ice snake, okay? The ice snake. Where do we put it? Does anyone remember from 494 or 440? Anyone? No? You do need to hear this again, okay? Where are we putting the ice snake? And it's not obvious, okay, without having some problems.
You gotta go like living entity, reptile, snake, ice
Yeah.
snake.
That's probably what I would do personally, but that's not perfect. It's not, it still has a problem with it, okay? So here's something you could do, okay? You could put it under Ice Panda, and this would allow you to inherit the ice features of the Ice Panda, which you need. But like now you got a bunch of panda logic in your snake, okay? This is a terrible idea. What are you doing? Okay? It makes no sense at all. It's going to be horrible. Under reptile is like the idea that I would go with, personally. Okay? You can do this. You can create a branch off of living entity, reptile, snake, ice snake. Okay? But there's a kind of a problem with this too, which isn't super fun. What is it? Yeah.
Like you may need to use some this implemented in the ice and you have to like rewrite it.
Yeah, basically there's a good chance we've copied some ice logic here, okay? We have ice logic implemented at different kind of areas of our chain, which could mean a dry violation, all right? Do you know what dry means? We've talked about dry already. It's don't repeat yourself. It's the idea that we never really, until maybe the very end of development, we don't want to have a whole lot of duplicated data and sources of truth, okay? And this is because we want to avoid copy-paste bugs. Has anyone encountered one of those in the semester so far? Like, okay, I'm going to copy-paste just a little bit, and you regret it? You always will, okay? It's going to get you, okay? The situation is this. You have some logic that's pretty great, and you need it at certain different parts of your code base. You copy it around, but oops, you have a bug in it. You discover a few days later. You copied it to 5 different places, but you only remember to fix it in 3 different places, which means you've got some latent hidden bugs there, okay? And that's very spooky and not very fun. So maintainability takes a dive. By the way, do you know what's the context in which you might decide to start violating dry hardcore? Okay, so yes, go for it. Performance is usually the most commonly cited answer I see is performance. And the indirection that you sometimes get from trying to preserve dry can affect performance. In particular, when it comes to things like ECS, I've heard a lot of studios start to duplicate their stuff just for faster iteration. But this can be a pain and cause problems. So you do it toward the end. I don't know a whole lot about that because I've never personally done it. But that's what I've heard. So keep that in mind. Anyway, we want to try and avoid placing redundant functionality into multiple locations of our inheritance hierarchy if we can. And so, what about under ice object? Well, this still doesn't fix our problem at all. I'm not even sure why I have it in this slide, okay? And so, it's just a pain. What happens if the ice panda melts during gameplay? This is like a really unnatural thing in our code base because we can't change the inheritance structure at runtime for an instance. That's not how this works. Now, what we could do is we could despawn. We could delete the ice panda and say, okay, we're going to instantiate a panda and try and copy over some of its stuff, which just feels weird to me. Okay, and so this is just very awkward, and it's a more common issue than you might think when you get big inheritance ISA chains going around. Okay, Here's a fun example that isn't even programming. Imagine that you got a bunch of photos and garbage on your desktop, which I usually do. Not right now, though. This is a new computer. See? See it? I just added a new folder. This is the beginning of the end today. Anyway, imagine you have a ton of garbage on your desktop and you're trying to sort it. Okay, so you got pictures of boats and pictures of cars. Okay, and this is all going really great until, oh no. Oh no. Okay, what do you do? What do you realistically do? What do you do? Personally, what do you do? Yes?
Put it in cars.
Why?
Because it's on wheels.
But it's a boat.
But it's not in the water.
It can be. I could have taken a photo of it in the water. By the way, this is what Meta puts their interns on to like in downtown Seattle. It's pretty cool. This is what I would usually do is I would just put it in one arbitrarily and hope I can find it later and remember which one I put it into. If I need to find it later, I have to check multiple folders to exhaust my options and trying to find it. It's not good. It's just awkward, right? These ISA hierarchies could just feel awkward in their rigidness. Now, one thing you might have heard of is a concept called multiple inheritance, and it might feel like a natural solution. Really here, what the ice snake needs to do is it needs to inherit from two different classes. It needs to inherit some stuff from snake and other stuff from ice object, okay? And this is banned by a lot of the most popular languages worldwide, like just wholesale. You're not allowed to do it. And if you ask for it, they'll just laugh at you on the forums, okay? I'm not entirely sure that this concept is the most evil thing in the world, but there are some issues you can run into, and the most famous one that you should know for interviews is called the deadly diamond. Here's the situation. By the way, this joke used to be way funnier. No one laughs at it now. They used to all laugh at it. It's so depressing. Anyway, you've got a human class, which has a function called sleep. You got a student class and an instructor class. Both of them override and change how that sleep function works. Unfortunately, you one day have a person who's both a student and an instructor at the same time. So the question for me is, because I'm both of these things, and I was in 2016, 2015, I was teaching 494 as a graduate student. Which version of sleep do I use? And some languages just don't have a facility to let you make this choice. I think C++ and Python do. But if you try this on on many teams, if there's any code review, they'll yell at you. You'll get one of the leads at your desk saying hello within a few minutes of you doing that pull request. Anyway, all right, this is called the deadly diamond, and you should know about it for interviews and stuff like that. It's just kind of fun trivia as well. We need a new approach. Okay, this just isn't working out, and it's not very fun. Programming should be fun, so let's make it more fun. Composition is kind of a new way to think about this. Think about code reuse. It's kind of this toolbox approach, okay? You don't really say that a duck, is a bird, which is a whatever, okay? Instead, have you ever heard that phrase? Have you ever heard that famous phrase, if it walks like a duck, if it sounds like a duck, if it looks like a duck, it's probably a duck. It might not be, but it's probably a duck. You can probably get away with treating it like a duck. And that's the spirit of composition, okay? You don't say a duck is a X. You say a duck has a bunch of feathers. A duck has the ability to swim. A duck has the ability to fly, okay? A duck has a hunger for certain types of food and insects and fish and stuff, okay? And that's how you build it. You use inheritance to set this up, but the general idea is that you have some sort of actor or entity class that is literally just pretty much a container for component type. And this might be like a panda or a snake in our case, okay? Or spot, or cuff, or our player, or our tile in your engines. Now, these component types are basically adjectives, okay? Right? It's the icy component. It's the fiery component. It's the has renderer component or is visible component. And these components derive from this one common type, and they've got a start function, an update function, like a cleanup or on destroy function, some lifecycle functions that the engine is going to execute on your behalf at the right time, okay? You just add the logic. It gets called automatically, okay? And that's what you see in a place like Unity, okay? This sine wave movement component is kind of cool because you can use it in multiple different places and on multiple different actors, okay? You write this code once, you use it in many different places. What does this code do? Take a moment to look at it, guess what it does. Pretty easy if you've taken 494, okay? What it does is it basically grabs a reference to your transform on this actor, on this game object. We need that reference because we need it to move the actor. It takes and keeps track of what the initial position of the actor is. And then every frames, it says, hey, my position, the position data, by the way, is always stored in a transform, right? We talked about that. It's the matrix, right? Our position is going to be the initial position we started at plus an up vector times sine. So you're going to go up, down, over time as the time gets fed through. It looks like this, okay? If you wanted to create a floating enemy, maybe you just had a sitting enemy, a turret. But now, once you slap this component on, suddenly it's a floating enemy. Boom, done, right? Maybe you had a ton of platform actors, which just kind of sit there. You can jump on them, but you want a floating one, right? Because it's a platforming game. And now you take that component you just slapped on the enemy, you slap that component on the platform. And now you've got a floating platform. You see? We've basically created adjectives, if you think about it. And we can slap those things on anything, as long as we made them well, okay? Sometimes you know your component isn't that well made. When you slap the component on something new, you're like, yeah, I'm going to make it float. Instead, it just explodes. And the errors start flying in the console. In EEX 494, we try and train everyone up to write hardy components that are just going to work. Just work TM in most situations. And that's what you want in a good component, okay? Anyway, when it comes to our original problem, a lot of these problems kind of go away, okay? So when it comes to creating a panda, you don't say, well, what is a panda? A panda is a mammal, which is a living... No, you don't say any of that. Instead, you say, what attributes make a panda the way it is, okay? Well, a panda has fur. So we create a fur component. And this might be a component that just renders our object in kind of a fuzzy shader or something like that. Now, the panda might have a carnivore component, which is going to kind of look out there for something that might be meaty, and it might tell the panda to go eat it, okay? The panda's AI. It has a living component, or maybe it has health component, which is going to be a storage. Basically, it's a component with a few floats in it that is like HP equals this, hunger equals this, hygiene equals this, bathroom equals this, right? The Sims component, basically. It has a renderer so that we can actually see it. The renderer component is responsible for gathering the mesh, the 2D geometry or 3D geometry, and actually rendering it to the screen. The panda might also have a herbivore component because pandas also eat vegetation in addition to meat. By the way, what happens when you combine the carnivore and the herbivore component? You get the omnivore effect, okay? Which is really nice. We didn't even have to write a new omnivore component to get that. We just kind of combine multiple components and we get it for free, right? It's really good. Anyway, we can take all these components, and if we add an ice skin component, a component that could basically just overlay our mesh with a blue texture and then add some of these white spots on it so that it looks kind of shiny, all right? Boom, we got our ice panda, okay? Not a big deal. If we go to create the zombie, the Lovecraftian component, we might create a flying component and a zombie skin component, okay? And for the ice snake, we can reuse some stuff. We can reuse the ice skin component that we built for the ice panda, and if we built it right, if we programmed it well, it should just work, TM, all right? Just for free. We can create these two new components as well. Compare this approach to the ISA, hierarchy of inheritance, okay? And I think the appeal is pretty clear. okay? The questions of where does the ice snake go, that was really troubling to us, is gone. The question of what happens if the ice panda melts is also gone, because the cool thing about components is that you can kind of add them and then pop them off at runtime if you want. Like that's how you do it. And it is not too bad. You can turn components off. You can just literally get rid of them wholesale. It's pretty cool. There's some bonuses here, like how to make the scaly panda. If you want to make like a snake-like panda, well, you just take the scales and the poisonous components and plop them on the normal panda. Maybe you got a panda then. How do you make the flying zombie snake? Well, take your snake, get rid of the ice stuff, put the zombie skin on and flying on, and you're good. Okay, done. You notice it doesn't take any code to mix and match components. Once they are built, once you have a lovely toolbox of high-quality components, your non-technical team members, your game designers, who, by the way, are usually less expensive for the team to hire, just saying, your game designers can come on and they can start mixing and matching and creating new types of content without having to come over and steal your time. I'll tell you, so one of the stories I heard about the Sims 3's development is that when you wanted to edit certain things and certain values in the game, like if you wanted to change how long it took a sim to drink a cup of tea, you had to as a designer, you had to go find an engineer who was bored or had some spare time and then ask the engineer to make the change. And then you'd check the change. And if you didn't like the change, an hour later, you'd have to ask the engineer to change it back or change it to something else. Okay? Nightmarish. Not good. Okay? So composition is really great for non-technical teammates. Now, there is a problem here that I've just skipped over. Okay? Did you notice it? We have another dry violation. Okay? We have another dry violation because, as cool as components are, we have a zombie skin and we have an ice skin. Duplicate logic. Uh-oh. It's no better. It's a wash. Forget all I said. Okay? How can we solve this dilemma? Is there any hope? Yeah.
Can we just use inheritance?
We can use inheritance. Oh my God. Oh my God. This is to say, and this is the big twist, that inheritance and composition are not necessarily rivals. They're two powerful, sometimes complementary tools in your toolbox. Okay? And so I hope you'll think of them that way going forward. Inheritance isn't always the answer. Neither is composition. And in fact, you can often use them together to get past some of your problems. Okay? In this case, we put our common skin logic into a base class for component, and then we can derive that functionality from the skin class into our children classes. Okay? So anyway, yeah, use them both. This is to say. All right, you can read more about composition, more formally about it, in the Gang of Four book. They like it. This is the money quote, favor object composition over class inheritance. Without much context, this isn't a super useful quote. It's so general, I'm a bit surprised it's in there. But it's in there. Does anyone have this book? The thing to note about this book is that it comes with a little strap on top that serves as like a built-in bookmark to the book. I don't think I've ever seen that before. But it felt high-tech, okay? All right, The Sims used this, okay? Part of your job on the Sims team was to create new components that could allow game designers to do new things, right? And for example, you could have components that might enable certain new interactions on certain objects. Slip and slide, right? But for instance, this stereo is something you could listen to. But that listen to functionality is something that might be associated with the TV as well, if you wanted to. Anyway, waiting line component was one of the things that I worked on. And that sounds like it's not that interesting. I assure you it was. In general, a fundamental thing about the Sims is that you can basically send multiple Sims at an interaction. The first one to get there will do it. The second one will get turned away. Well, now, if you put a certain component on, you don't get turned away, and you build up a really cool waiting line. Okay? Anyway, how do you get composition? We got 1 minute left. I'm going to go really fast. Composition in Unity, you get it for free. Okay? That's how you do everything. All right? You write a C# script that becomes a component. You put that component on something. You get behavior. Okay? In Unreal Engine, same thing. Now, you have some other options in Unreal. It isn't as obsessed with composition as Unity is. But You write a component, you put it on an actor, it does the thing, okay? In this course, okay, in your game engine, right, you are going to write components as Lua files. You will associate them with actors via your scene file, and you can overwrite properties, you can change the properties, right? And if you write enough components and they're high quality enough, you'll get the behavior that you want, okay? So how to build a composition framework, you can do this in C++. It's not quite as hard as you think. You do need a base class for components. You can make them virtual functions. Thus, any components like transform component that you implement will have these functions automatically run for you. Transform doesn't care about those lifecycle functions, though. It's kind of just a container for certain positional, rotational, scaling data. And you can have an entity, or we would call it actor these days, and that could be something like a vector of component pointers or something else if you want. Yeah, you've got your update function, which just runs through all your components and calls update on them. And you've got the add component function, right, where you can define what kind of component you want. You will implement that, or you will allocate that component, push it on to your vectors array, your components vector, call the start lifecycle function on, and then return the pointer in case the calling code wants to do something with that component. Customize it, do whatever they want. Okay, store it. And thus, you can get a situation, an example, where you've got your actor. You can add different components to that actor at runtime, right? You can grab certain components on that actor, mess with them, call functions on those components. And then, for instance, here we're setting the position, and when you render out where the actor is, you're going to see those changes. You can then call update on the actor, or the entity, and that will update all the components, aka that's what you do to end the frame, kind of. Then it works the way you'd expect, okay? Not too crazy, okay? So your summary, flexible alternative to inheritance can be mixed and matched at runtime. It's really great for any sort of scenario involving properties and experimentation. It may work well with inheritance. And here's the big takeaway, okay? Composition is all about iteration. It's all about making it easy to mix and match and experiment and try new things. If you've taken any of my other courses, you know that game dev and creative works are all about that iterative process. The faster that you can get something working and then test it and then change it and then get it working and test it and change it and working, test it, change it. The faster you can go around that loop, the better your game will be. And I've seen a lot of productions that really struggled and had a bad outcome or a mediocre outcome. And all those productions are marred by long iteration times, okay? I hear from students who tell me, right, that, hey, Austin, like I haven't built my code or tested my code or my new feature in like 6 days. I actually have heard like, yeah, I haven't been able to build this month because like the build is broken and no one can get anything in and no one can figure out how to fix it and there's no real pressure to fix it and our dev time and money is burning up and the game is due in 6 months and the campaign hasn't been started yet. And it's just a disaster. But I've also heard of dev teams that are like, yeah, I like make a change in my code base and I run a little hot reload command and my Lua components all refresh and I'm already testing the new enemy AI. Okay, and I don't like it. 5 seconds later, I don't like it very much, so I make another change and I test it again and now the enemy is shooting at me, right? And it's really fun to try and dodge it. And it's amazing, right? Those games tend to be, they turn out okay. I would say at least it's a huge advantage, okay? So in creative spaces, it's very hard to know how good your game is unless you're testing it constantly and with a diverse crowd, or at least a target audience, okay? And so you need to iterate fast, and composition is fantastic at that. Absolutely incredible, okay? Better than just standard vanilla inheritance. That is all I have for you, everyone. I hope you have a fantastic break. I hope you enjoy this homework 7. Hopefully it won't be if we're being honest, I'll probably have to fix some stuff, okay? But I hope you enjoy most of your time with this homework. Nikhil seems to be enjoying it. I loved doing it and making it for you. And I hope you have a really restful break, okay? Don't work too hard over that break if you can. just relax, recharge, and we'll see you back here in a week or two, okay? See you then. Office hour starts now, and let me know if you got any questions. All right, take care, everyone. Bye-bye.